Okay, welcome to tutorial 1. Okay, for the question 1, determine the charge and the mass in U. So it's very important that to take note is U, okay, of the nuclear made up of the following particles. So if you remember from the lecture, okay, you will know that the mass, okay, if it's in U, proton is 1, neutron is 1, electron is 1/1836, okay. So that is the one that you need to know. Okay, so very simple. So we know for this A there are 3 proton and 4 neutrons. Okay, so since we know that this is 1U, this is 1U, so just multiply 3 times 1 and 4 times 1 plus together, then you know the mass in U. Yeah, so in total is 3 plus 4 is 7U. Okay, so it's 7U. For the charge, okay, for the charge, it will be you know that proton is +1, okay, neutron there's no charge, so for this is going to be 3 plus, okay, for this nuclei. Yeah? How about this one? 10 proton, 12 neutron. Okay, we know 1U for this, 10 plus 12. Okay, 10 plus 12 equal to 22U. Okay, then we know that proton is +1, neutron there is no charge, so it will be 10 plus. Okay, positive charge, there are 10 of them. Okay, then this one you just add up. Okay, 1U, 35 plus 46 equal to 81. Okay, U. Alright, 81U. Then positive 1, there's no charge, so is 35 plus. Okay, so this atom contains is positive 35. Yeah, so in this case we are just considering the number of protons. Yeah, so since this is given, yeah, okay, there's no information regarding the electrons. How about this? So it's 56 plus 81. Okay, so the answer will be 56 plus 81 equal to 137U. For this proton is +1, there's no charge here, so it's 56 positive. Okay, so this is the mass. Okay, so these are the charge. Okay, alright, that's for question 1. Okay, moving to question 2. Okay, so for question 2, determine the number of electrons, okay, that will have to be associated with each nucleus described in question 1 to produce a neutral atom. So this is a keyword, neutral atom. Okay, neutral atom means what? Neutral atom means that there's no net charge. Very important. Yeah, there's charge, but just that when you add up together there's no net charge, so there's equal amount of positive and negative charge. Okay, so in this case A, in order for you to become neutral atoms, so since it got 3 positive, so there should be 3 electrons, okay, to generate 3 negative. Okay, so very simple, that's the answer. 10 plus, so there will be 10 negative. Very simple. Yeah, all these are just based on the concept. 35 negative, and this will be 56 plus 56 negative. Okay, so these are the answer to produce a So you can see positive, so the net charge is 0, net charge is 0, 0 and 0. Okay, so no net charge. Okay, so that's it for question 2. Okay, for question 3, okay, determine the number of protons, okay, number of neutrons, number of electrons in the atoms of the following isotopes. Alright, so here you will see, okay, how you see over here, you can refer back to your lecture notes. Alright, so you can see this is the symbol, here is the nucleon number, this is the atomic number. Nucleon number is where you add up the number of proton and number of neutrons. This one is the number of proton. Okay, so over here you know that the number of proton and neutron add together is 7. This is number of protons, so number of proton is 3. Here number of neutron is 7. Okay, because this one is protons and neutron add together. So if you want to find neutrons, so you need to subtract the proton. So number of neutron equal to 7 minus 3 equal to 4. Okay, so in this case, if you are talking about the atoms, it asks you for the number of electrons. So we would make the assumption that is electrically neutral, which means that there's no net charge. So you just follow the number of proton over here. In this case, the electrons will be 3. Okay, will be 3. Okay, very simple. So over here, the number of proton is 10. As you get down there, proton 10. Neutron is where you have the nucleon number, which is 22 minus number of protons, so equal to 12. Okay, electron is assuming that it's electrically neutral. Okay, so net charge, so it will be 10. Okay, here same thing, number of proton equal to 20. Number of neutron equal to 44 minus 20, so it's 24. Number of electron will be 20 in this case. Okay, so all these are will be the answer. Okay, that's it for question 3. Okay, for question 4, what are the symbol and name of an element? Okay, I ask you to find out this element whose average atoms have a mass that is 77.1% of the mass of the average chromium atom. Okay, so that we know that the mass is smaller. Okay, 77% smaller than the average chromium atoms. So we need to go to the periodic table elements to find out the number of the mass of the chromium atom. Okay, so you dig out your periodic table elements. Okay, to find chromium. Okay, I see chromium is here. Okay, just zoom it in. Okay, so chromium, the atomic weight, you can see from here at the top right hand corner, all these are atomic weight. Top right hand corner, the atomic weight is 52U. Alright, so 52U. So we know that the chromium is 52U. So if you're looking at 77.1% the weight, okay, since we know that the mass of that unknown element is 75% of the weight of chromium, so we just multiply 52 with 77.1%, so it would be 40.092U. So with this number, you go back to the periodic table of elements. So 40 point something. So we look at the closest 40. Okay, over here the closest 40.08 would be calcium. Okay, so the answer would be, for this, it will be calcium. Okay, alright, the name and the symbol is Ca. Okay, symbol Ca, name is calcium. Okay, that's it for question 4. Okay, for questions 5, okay, so calculate the atomic weight of lithium on the basis of the following percent composition and atomic weight of the naturally occurring isotopes. So we know that the lithium, in this case, if you look at that, alright, and then compare the calculated value with that on the periodic table elements here. Okay, so that's simple. So first is we need to do this part. Okay, so looking at here, we got 2 isotopes here, and this is the percentage that it occurred there. So these 2 isotopes, so we need to find the average. So what we do, if you look at this, right, these 2 numbers, okay, if you add up, okay, if you add up, it will be 100%. Yeah, so this one will be 100%. Okay. Alright, so in this case, you are more or less safe to say that, okay, there's only these 2 isotopes in these elements. So how do you calculate the atomic weight of lithium? Is by using the calculate the average abundance of these 2 isotopes here. So very simple. What you need to do is the so you write there, atomic weight of lithium, okay, is, okay, for the isotopes lithium 6, okay, which is 6.0151 U. So the abundance is 7.42%. Okay, so you just calculate that, okay, plus 7.016 U times 92.858%. Okay, so just calculate that. Okay, this is how you calculate the, so it will be 0.44632 plus 6.495. It's okay, you just use up more decimal place here. So it will be 6.9417 U. It's okay to have more decimal, no problem, okay, in this case. So for lithium, okay, lithium, it will be 6.9417 U. Okay, let's compare it with that in the periodic table elements. Okay. Okay, 6. There you go. Okay, lithium 6.941. Okay, how does it compare with that? It's the same. Okay, the one we calculated based on that. Okay, so now you know that the lithium is based on the is composed. Actually, you can make it another way. It's composed of these 2 isotopes. Okay, so they have a number of 3 protons, just that they have a different number of neutron. Okay, and we know that if anyhow we got the lithium, okay, we get it the lithium, so from that 92% is going to be it will be majority lithium 7, just minority is lithium 6. Yeah, alright, this is the major composition of the lithium, and the average based on these 2 is 6.941, which is the same as that you see in the periodic table element. Okay, So that's it for question 5. Okay, question 6. Refer to the periodic table and determine how many grams of phosphorus contain the same number of atoms as 0.12 gram of carbon. Okay, so when you look at this, when it mentioned number, okay, the number you can safely assume they are referring to the mole quantity. Okay, mole quantity, no problem. So in this case, we no longer can use U, the unit, so we need to convert to grams per mole. Yeah, the weights we need to convert to grams per mole. So just to refer back. Okay, so what you need to do, okay, go back to lecture notes. Okay, whatever atomic weight you find from the periodic table, just convert directly. It's a direct conversion, yeah, to what we call molar mass, which is grams per mole. In this case, we can have the grams and we know the number. Okay, the weight and the number for each of the atoms. So very simple. Since it's the question is asking how many grams of these contain the same number of atoms as 0.12 gram of carbon. In this case, we need to find out 0.12 gram of carbon, they contains how many, okay, how many moles are there. Okay, so first find the molar mass of the carbon. In this case, the carbon molar mass. Okay, what is the number? You just go back to the periodic table of element. Okay, and look back to carbon. Okay, carbon, you can see over here is 12, yeah, 12.011. In this case, the molar mass will be direct conversion 12.011 grams per mole. Okay, every 1 mole there is 12.011 gram, yeah. Okay, every mole there's 12.011 gram. That's the meaning of it. Okay, so how many moles are there? So in order for you to find out how many moles, so what you do is directly use the 0.12 gram divided with the 12.011. So number of mole for carbon, okay, equal to 0.12 gram divided by 12.011 grams per mole. Okay, so it's equal to okay. So it's equal to 0.00999 mole. Okay, yeah, 599 mole. So now we know that 12.012 is that much. So now we need to find out 0.0999 mole. Okay, because now how many grams of water contain the same number as this. So now with the same number, which is this, we need to find out how many grams is it in. Okay, so now we need to find the molar mass of the phosphorus. Okay, so molar mass of phosphorus, go back to the periodic table of element. Phosphorus is 30.974. Okay, 30.974 grams per mole. Okay, so you want to find out the number of grams of phosphorus equal to 30.974 grams per mole multiplied by 0.00999 mole. So in this case, okay, times 30.974. Okay, so the answer will be 0.394 grams. Okay, so now we know that, okay, assuming that we got same number of moles between carbon and phosphorus, okay, the weight is different, yeah. The carbon is a lot lighter compared to the phosphorus. Okay. Okay, question 7 will be very similar to question 6. So refer to the periodic table element, determine how many grams of fluorine contain the same number of atoms as 1.6 gram of oxygen. Okay, so again, same number, you need to find out what is the number for this oxygen. Okay, so it will be, okay, just to make it quick, so oxygen, the molar mass is 16. Alright, so fluorine is 19. Okay, so the molar mass, you can do this very quickly. Find out molar mass of fluorine, okay, is 19 grams per mole. For oxygen, okay, it will be 16 grams per mole. Alright, so you find out the oxygen. For oxygen, how many number of atoms are there? So the number of atoms of oxygen equal to 1.6 gram, okay, divided by 16 grams per mole. So in this case is 1.6 divided by 16, so it's 0.1 mole. Okay, so because now we say the same number, so we just use this number and multiply the molar mass of fluorine. So in this case, number of grams, the grams of fluorine equal to 0.1 mole multiplied by gram mole. Okay, so it will be multiply 1.9 gram. Okay, so this answer. Okay, okay, question 8, very simple. Identify the number of and the period to which each of the following elements belongs. We got calcium, element number 22, nickel, tin. Yeah, so it's very simple. Group and period. Okay, so for calcium, okay, I'll just do one for you. This is very easy. Yeah, so calcium, okay, we see over calcium, so it will be group. As I say, group is look through here. Okay, group 1, group 2, group 3, group 4, and so forth. So it's group 2, period 4. Okay, so in this case, this one will be group 2, period 4. Very simple. Okay, so you can do the rest of it. It's very simple. Okay, question 9. How many orbitals are found in the third shell? Write the designation for the orbitals. Yeah. So how many orbitals are found in third shell? So if you are looking at third shell, okay, back to the lecture notes for the okay, this is the third shell. Okay, so how many orbitals are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, because we got 3s, 3p, and 3d. Yeah, 3s got 1 orbital, 3p got 3 orbital, 3d got 5 orbitals. Yeah, so 5 plus 3 plus 1. Okay, in total is 9 orbitals. Okay, so in this case there will be 9 orbitals. Alright, okay, for the designation of orbitals will be 3s, 3p, and 3d. Okay, so this is the answer. Okay, the last questions. Question 10. How many orbitals are found in a d subshell? Okay, in d subshell, the number of orbitals is 5. Okay, what is the maximum number of electrons that can be located in the subshell? Okay, in this subshell, there's 5 orbitals. Each orbital can have 2 electrons. So in total, there will be 10 electrons. Okay. Alright, that's it. Okay, so that's it for this tutorial 1.